GCSE Physics, Sound Waves, Smart Path, Tutoring. Sound travels as a wave. Sound waves are caused by vibrating objects. These vibrations create sound waves. Sound waves are longitudinal waves. This means the vibrations are parallel to the direction the wave travels. Sound is a type of mechanical wave, so it needs particles to pass the vibration on. Sound generally travels fastest in solids, then liquids, then gases. This is because the particles in solids are much closer together, allowing vibrations to be passed on more quickly. A sound wave consists of alternating regions of compressions, particles close together, rarefactions, which are particles spread further apart. As the sound wave travels, the particles vibrate backwards and forwards about their fixed positions. The particles do not travel with the wave, they simply pass the vibration along. Sound cannot travel through a vacuum because there are no particles to vibrate. Sometimes the sound wave eventually reaches someone's ear and they hear the sound. You hear sound when your eardrum vibrates. Sound waves enter the ear canal and reach the eardrum. The sound waves make the eardrum vibrate. These vibrations pass through the tiny bones in the middle ear. The vibrations are transferred to the cochlea in the inner ear. Inside the cochlea, hair cells detect the vibrations and convert them into electrical impulses. The electrical impulses travel along the auditory nerve to the brain. The brain interprets these signals as sound. Different frequencies produce different pitches. For example, low frequency is low pitch, high frequency is high pitch. Humans can normally hear frequencies between 20 Hz and 20,000 Hz, 20 kHz. How loud a sound is depends on the amplitude of the wave. Larger amplitude is louder sound, smaller amplitude, quieter sound. Sound waves can reflect and refract. Sound waves are reflected by hard surfaces. Examples include cliffs, walls, mountains. Reflected sound waves are heard as echoes. Sound waves can also be refracted as they pass through different materials or regions where the speed of sound changes. They bend. When sound travels through air at different temperatures, its speed changes. This can cause the sound wave to bend, refract. Key facts to remember. Sound waves produced by vibrating objects are longitudinal waves, need a medium, solid, liquid or gas to travel, cannot travel through a vacuum. Compressions and rarefactions. Compression equals particles close together. Rarefaction equals particles spread apart. The particles vibrate backwards and forwards, but they do not move along with the wave. Hearing. Sound enters the ear canal. The eardrum vibrates. Vibrations pass through the cilia, tiny bones. The cochlea converts vibrations into electrical impulses. The auditory nerve carries the signals to the brain. Pitch and loudness. Pitch depends on frequency. High frequency is high pitch. Low frequency is low pitch. Loudness depends on amplitude. Larger amplitude, louder sound. Smaller amplitude, quieter sound. Reflection and refraction. Hard surfaces reflect sound, producing echoes. Sound waves can also refract when their speed changes, for example, in air at different temperatures. Exam tips. Sound waves are longitudinal, not transverse. Sound needs particles to travel, so it cannot travel through space, a vacuum. Remember, frequency determines pitch. Amplitude determines loudness. Human hearing ranges approximately 20 Hz to 20,000 Hz, 20 kHz. Echoes are produced by the reflection of sound waves. Thank you for watching. Please don't forget to subscribe and like the video.